Hello, we are Group 8, and we are part of the Conductor Evaluation Group with Dr. Scott Luberoff as our sponsor.
Hi, I'm Alex, and I worked on the back end.
I'm Allison. I worked on the analytics.
Hi, I'm Gabriel. I worked on also analytics.
I'm Jonathan. I was the project manager, and I worked on the back end.
I'm Noah. I work primarily on the front end.
And I'm Raphael, and I worked on the website and some user preferences scenes. So for the scope of this project, we were tasked with making a tool, an app that you can download and record a conductor conducting, and it's used primarily by conductors and educators in order to evaluate their conducting and their conducting skills.
So the first thing we wanted to do is really get a grasp on our users. And that includes what the job is of a music conductor. Fundamentally, they keep time for their ensemble, but they also lead them creatively, making musical decisions. For the conductor to be successful, their technique needs to be well established and perfected, and that's where conduction comes in. Conduction is a tool for instructors to evaluate their students of any level from high school to university and help their students improve their technique.
There's three planes to be aware of. The sagittal plane, which is the forward and backward space, the vertical plane, which is the upward and downward space, and the horizontal plane, which is the rightward and leftward plane. All these are really important when evaluating a conductor, and our program helps measure and track this.
Our project came about due to a previous group working on the same project. They used the Xbox Kinect as their primary motion detecting camera, which caused compatibility issues with Mac, which is what our sponsor was looking for, as the music department mostly uses Macs. So that is the reason we are doing a version 2.
These requirements are built off of our collaboration with our sponsor, Dr. Luberoff, and requirements that were passed from the first version of the project. And these are divided into 4 sections: functionality, recording, markup, and analysis. For functionality, we need to make sure it works on Mac and Windows, because it's important for it to work on Mac because majority of the music department uses Macs for all their music related things. And for recording, it is important to have a built-in metronome and record audio so they can get some audible feedback. For markup, it is important to rotate the model and write annotations on the recording so they can have some visual feedback, and analytics so they can utilize customized trails, movable access lines, and have informative analytics. Throughout our semester, we were trying to reach some milestones and goals. That is to include an avatar selection screen, to have a website to host our project build, and to work on, or to have a working product for the conductor symposium that was held in February. Some of our stretch goals were to have the ability to upload videos taken outside the app and to track over time.
So for technologies used, we built everything in Unity. For our mapping of our skeletal model, we use Blaze Pose Barracuda. You do need a camera to run the app. It can be any camera that's connected to your computer, be your webcam, or an external camera. We use GitHub for version control, Firebase to host our website, and Discord for communication amongst all the group members.
For our project management, we made sure to meet at least once per week, typically on Mondays and Wednesdays. We use a Scrum-like approach for our methodology, and we used Jira in order to track a lot of that and keep track of our progress. For meetings with our sponsor, we made sure to meet with him bi-weekly via Zoom and sometimes in person. And for communication, we made sure to, when we couldn't meet in person, to keep in touch over Discord.
We had a variety of camera options to choose between, and we tested many different things. The first camera we tested was Intel's RealSense. This seemed promising as the previous group to work on this project recommended it for future iterations. But upon further testing, we found it did not work well with Macs at all, which caused us to switch to the Oak D camera by Lexonis. They had a really great support team, which allowed us to reach out and ask a lot of questions. However, on the Unity side of things, the camera is still in development, and not everything was ready for Mac, which caused it to have problems for us.
After having trouble with the cameras, we experimented with Apple's AR kit. It's basically their library that uses the LiDAR sensors on newer Pro models of their iPhones and iPads to track things in 3D space. Would have been a really good option because it was portable and a lot of people have iPhones, but it was not a good option for us because none of us have much experience in Swift, and not many of us have Pro model iPhones or iPads to be able to test our eventual application with.
So when looking at pose estimation, version 1 used the Kinect camera, but they also used the Kinect SDK. So when we came in, we had to find a new way to pose for pose estimation. When we settled on the OAKD Pro, we also looked at Luxonis's SDK Depth AI. This was a great option at first. It had very accurate 2D tracking, a built-in recording function, which we needed, and as Noah mentioned, a lot of support from Luxonis. They had a very active Discord server. One of the biggest issues, though, was that the 3D tracking was just inaccurate, and there was also a lot of large overhead with video data storage. Like I said, their support was great, and when they were unable to help us with our issues, they pointed us to Google's MediaPipe Pose.
So like Alex said, we ended up using the Google MediaPipe Pose for a few reasons mainly. First of all, it was had integration with Unity, as well as it could use any webcam, meaning we weren't tied down to use a 3D specific camera for our tracking. It had very accurate 3D tracking for using a webcam, and it also has the capability of analyzing already existing videos from file selection. For some of our difficulties that we had with this pose estimation software was that most of the back end from the old project had to be redone, as well as we had some issues saving recordings at times, but we were able to overcome those in order to utilize the benefits that this provided.
So the image on the left shows the original design of the analytics dashboard, where we have 4 graphs instead of just 2. And the image on the right shows the current version, which is just 2 graphs. And the reason why we dropped the other 2 was due to time constraints and basically deeming them not very useful for the user. So the use of space graph just tracks each hand and how it uses its given space, and the tempo tracker tracks the tempo. So both graphs were remodeled. The prototypes included the summary section, which was eventually taken out because it just wasn't useful. And the tempo tracker had some new features, such as a button to access the playback video and tooltips so you can see the data properly. So the tempo tracker plots a point at every 2 seconds as corresponding time label. The user can also enable and choose a value for the metronome and have that line displayed on the graph as well.
For the website, we wanted to make a website to host our project, have a contact form, basic information over the project, and download links to our project. We built it using React. It's hosted on Firebase, and we used email.js for the contact form. So anything that's filled out in the contact form gets sent to us in an email for a quick response.
So now I'm going to talk about some of the events where we had some testing and feedback. In early February, we had the Conductor Symposium. Some feedback we got from there was to include a thumbnail of the recorded video to the playback screen, so instructors can pinpoint where in the video the avatar is corresponding with. In March, a meeting with Dr. Luberoff resulted in some feedback to also include that video in the tempo tracking screen, again, to kind of correspond the recorded video with where the tempo is varying. Finally, in April, we did some user testing with some of the graduate conductors here at UCF. Something that came from that was to add a menu to select which webcam to use, meaning we could use a built-in webcam for a laptop, any external webcams, or even an iPhone.
To kind of wrap up our successes and difficulties that we've had throughout the project, we had, as far as the cameras went, the end product is able to use any webcam, which is a huge benefit, and it has very accurate 3D tracking. as well as we have an analytics page, which wasn't previously implemented. As far as difficulties, we had to go through 2 cameras before we landed on the blaze pose method, and our pose estimation doesn't work well on noisy backgrounds or with poor lighting. And finally, for our analytics, our tempo tracker accuracy might be a little off at certain times.
Some future things that we'd like to see from a version 3 of this project would be an integrated grading feature. This would make it easier for instructors to grade their students. Students would be able to create users where they could view their performance history, how they're doing. Instructors would have an easier time seeing how their students are improving and doing. And then a website so the application would not be needed to see feedback and your grades.
Thank you for watching, and we hope you enjoyed.